Welcome to Mac TV with Professor V. I found a fun little integral this morning. I hope you all enjoy it immensely. We have indefinite integral of 1 over x minus 3 rad x plus 2 dx. And I will include the directions because they do have a bit of a hint, and it says do basically a u substitution and then another integration technique. So if you want to play around with it, pause the video. I'm going to jump right in. I'm going to let u equal rad x, and I'm inclined that way because I notice the denominator is quadratic in form, meaning if I make this change of variables, then I will have a quadratic function in terms of u. So if u is rad x, then that means u squared is equal to x. And now let me differentiate both sides so I can rewrite my entire integral in terms of u. So derivative of the left-hand side will be 2u du equals 1 dx. All right, so let's see, this is going to really get the ball rolling. In the denominator now, instead of this x, you see this x? I'm going to replace it with u squared minus 3, instead of rad x, what do we have? U, very good, plus 2. And then observe this sweet little dx, I'm going to replace with 2u du. And I'll put it here like this, 2u, and then let's just put the differential du out there. All right, so notice, yes, we have lovely little quadratic expression here. And then I'm looking, okay, I have a rational function. I'm thinking maybe I should do some partial fraction decomposition. Yes. And before you hop to that, make sure degree of the denominator is higher than the degree of the numerator. It is, right? This is degree 2, this is degree 1. So I can do my partial fraction decomp. If the degree of the denominator wasn't higher, then you would need to long divide first, okay? And then just do partial fractions on the remainder. So here we go, partial fraction decomp. You can factor out the 2 from the integral, but since I'm doing partial fractions, I'm just going to leave it, and the decomposition will take care of it. So we have 2u over, now let's factor that denominator, u minus 2, u minus 1. Both of these factors are linear, and they're not repeated. So the decomposition will have the form a over u minus 2 plus b over u minus 1. And then in the next step, we clear out the fractions, so multiply by u minus 2, u minus 1. And then on the left-hand side, I just have 2u equals a times u minus 1, because u minus 2 will cancel, plus b times u minus 2. All right, very nice. Now, let's focus on this equation here and try to solve for a and b. I'm going to let u equal 1. I'm choosing that because that will make this factor a 0, okay? So if u is 1, 2 times 1 on the left is equal to a times 0 plus b times negative 1, which tells me b is negative 2. Okay, and then similarly, I'm going to let u equal 2 because that will let this other factor equal 0. And then let's see, on the left we have 2 times 2 equals a times 2 minus 1 plus b times 0. And then now I can see, a is equal to 4. See how harmless that was? Okay, it's going to irritate me. Yes, there we go. So now we have the following integral. A was 4 over u minus 2. And b was negative 2, so then I have minus 2 over u minus 1, parentheses, parentheses, du. Lovely. Both of these antiderivatives you should be pretty familiar with. So first one, just keep the 4, then you have natural log, absolute value, u minus 2, minus 2, similarly, natural log, absolute value, u minus 1, put the plus c immediately, all right? The integral sign, the differential du go away once you take the antiderivative, and then you need to put plus c when you have an indefinite integral. indefinite, meaning there's no limits of integration on it. Okay, I know you might feel really excited and want to box this, but this is not our final answer. Remember, the original integral was in terms of x, and we made the substitution that u was equal to rad x. So we got to go back to the OG variable for ln absolute value rad x minus 2 ln absolute value rad x minus 1 plus c. And now we are done. So that concludes the video. Give it a thumbs up, subscribe if you haven't already. You can also check me out on Instagram and TikTok, Math TV with Professor V. Have a great one, you guys. I'll be back soon.